Hello everyone, I am Mr. K Kulkarni, working as an assistant professor in Department of Mechanical Engineering at Walchand Institute of Technology, Solapur. In today's session, we will be discussing about the open belt drive. At the end of the session, the students will be able to understand the basics of open belt drive. They will be able to derive the length of the open belt drive for open belt drive. They will be calculating the length of the belt for open belt drive. So first we will understand what the belt drives are. A belt drive is a mechanism used to transfer power between the shafts using a continuous belt. Broadly, belts are categorized as open belt drive, crossed belt drive and a combined belt drive. So we will understand what is meant by open belt drive. As you can see, this is a pulley 1 and this is a pulley 2. Okay, so this is a driving pulley, this is called as a driving pulley and this is called as a driven pulley, and these two pulleys are connected by a belt, and the direction of rotation of these two pulleys is same. That means the pulleys rotate in the same direction. So open belt drive is a belt drive where pulleys are rotating in the same direction. These belt drives are typically used in machines like conveyors, engines and other mechanical systems. We will see the components of an open belt drive. The first component is the driving pulley or a driver pulley. So the driver pulley is connected to the power source. So in this figure you can see this is called as a driving pulley. Second one is the driven pulley. The driven pulley is driven by the driver pulley. In this figure this is called as the driven pulley. Both the pulleys are connected by the belt and power is transmitted from driving pulley to driven pulley by using this belt. In addition, we require a tensioning mechanism so as the belt will not slip. So an idler pulley or an adjustable bracket is used for giving the required tension. If the tension is reduced, there will be slip in the belt. Open belt drive has certain advantages. That is simple in design. We can design it very easily. It is inexpensive. It has the flexibility that we can change the center to center distance of the pulley, and it has a shock absorption capacity because it does not create more vibrations as compared to other arrangements. It has certain limitations like slippage. If the tension is not maintained, you can have slippage in belt. It is not particularly used for higher torque transmission. That means limited torque transmission is there in the open belt drive. There is our efficiency losses as well as you have to change the belt periodically. These are certain limitations. Applications are agricultural machineries like harvesters and threshers, manufacturing machines like lathe machine. They are also used in conveyor systems as well as industrial ventilation systems. Now we will see the derivation of length of open belt in an open belt drive. So the derivation, it helps in designing an efficient system that minimizes friction as well as power loss. So we have to calculate the length of the belt that is optimized. The length is affected by radius of pulleys and the center distance between the pulleys. These are the two parameters that affect the length of the belt. Now we will see some parameters that are there in the derivation. First parameter is the radius of the smaller pulley, that is denoted by R. So in this case AC is the radius of smaller pulley. Capital R is the radius of larger pulley. In this case BD is the radius of larger pulley. Capital C is the center distance between the pulleys. So in this case we have AB as center distance, and beta is the angle subtended by each common tangent on the center of the pulley. So in this case we have angle CAJ as the beta angle and angle DBK as the beta angle. So it is the angle subtended by each common tangent on the center of the pulley. Now the length of the belt can be calculated as the length of arc GC plus this center distance CD plus DH, length of the arc DH. That means addition of arc GC plus CD plus arc DH. As this is symmetrical, we can multiply it by 2. So the total length of the belt that is required is twice arc GC plus CD plus arc DH. Now we will calculate the individual components. First component is length of arc GC. As we know, the length of arc can be calculated by the formula radius into angle. So the radius of arc GC is small r because it is associated with the smaller pulley, and the angle subtended is angle CAG. This is the angle subtended by the smaller pulley. So this is angle CAG that we can calculate as this 90 degree minus this angle. This angle is beta. So 90 degree minus angle CAJ, that means this pi by 2 minus beta, that is called as angle CAG. So length of arc GC is equal to pi by 2 minus beta into r. Next, CD. As you know, CD is equal to AN. Both lines are parallel, so we can assume that CD is equal to AN. So in triangle ANB, in right angle triangle AN and B, angle right angle is ANB. Okay, cos of beta, this cos of angle beta is equal to adjacent side AN divided by hypotenuse AB. So cos of beta is equal to AN upon AB, which gives AN is equal to AB cos beta, and the value of AB, as we know, is C, center distance C. So AN is equal to C cos of beta. Third component, arc of DH, length of arc DH can be calculated by the same procedure, radius into angle. So length of arc DH is equal to angle subtended by this arc is DBH, which is this 90 degree angle KBH plus angle DBK. So this is 90 degree and this is angle again beta. So pi by 2 plus beta into r. Length of arc DH is equal to pi by 2 plus beta into capital R. So substituting value of these three values 1, 2 and 3, we get to the length of the belt is equal to 2 into pi by 2 minus beta into r. So substituted this value plus C cos beta plus pi by 2 plus beta into r. So expanding these terms, we get 2 into pi by 2 into r. So 2 to cancel, so pi into r. This is the first term. Minus 2 beta r, this is the second term, plus 2c cos beta, 2 into c cos beta, plus 2 into pi by 2 into r, that is pi r, plus 2 into beta into r. So taking pi common from first and fourth, so pi into bracket r plus r plus 2 beta bracket into r minus r plus 2c cos beta. This is the exact length. Now if we approximate for small value of beta, we get sin beta is equal to this formula, r minus r upon c, and cos beta we get 1 minus half r minus r bracket square upon c square. So L is equal to, substituting this value of sin beta, so this will stay as it is, plus 2 into taking the value of beta as r minus r upon c into bracket r minus r plus 2c 1 minus half r minus r bracket square upon c square. This is the value of cos beta. So after expanding these terms, we will get L is equal to this value pi into r plus 2c r minus r bracket square upon c. So this is the approximate length. These are the references that we have referred. So thank you.